The primary structure of a lined ball valve comprises left and right valve bodies along with the packing gland. The two valve bodies achieve sealing through 4 central bolts, while the upper packing gland utilizes for hex socket head screws to compress packing material, thereby ensuring stem sealing. Consequently, when addressing valve leakage or packing leakage, a fundamental understanding of its internal architecture is essential. As demonstrated in this disassembled lined ball valve, the left and right valve bodies exhibit symmetrical configurations. Their sealing performance primarily relies on the uniform width and polished surfaces of the internal fluoroplastic lining. Casing leakage typically originates from failure of these sealing interfaces, allowing medium escape. Notably, fluoroplastic materials inherently possess cold flow characteristics. After prolonged compression from ball preload forces during valve assembly, gradual cold flow deformation of the fluoroplastic may reduce ball clamping effectiveness. Therefore, for valves in long-term storage, it is recommended to conduct secondary pressure testing prior to installation. This includes verification of body sealing integrity, packing performance, and internal sealing functionality. Should packing leakage or external valve body leakage be detected during inspection, appropriate tightening of the corresponding fasteners should be implemented. Critical considerations include maintaining uniform ball torque during tightening operations, avoiding overcompression that might induce plastic deformation of fluoroplastic components, adhering to manufacturer-suggested tightening sequences, conducting pressure integrity testing post-adjustment to validate remedial effectiveness. When seal failure occurs, how to solve it? When installing a valve on a pipeline, with one side designated as the left pipeline and the other as the right pipeline, the following procedures and precautions must be observed. First, ensure the parallelism of the flanges at both ends of the pipeline. If deformation or misalignment exists between the flanges, adjustments should be made using compensators or expansion joints. Failure to address misalignment may subject the valve to axial or radial forces, leading to seal failure at the valve body and subsequent external leakage. If leakage occurs at the packing or valve body, after proper installation, confirm flange parallelism and correct flange gap. Proceed as follows. Valve body leakage. Directly tightening the valve body bolts is often ineffective due to pipeline tension caused by fixed supports or thermal expansion. Please refer and follow as below. A. Keep one flange, for example, the left side, fixed and loosen the opposite flange bolts to a free state without full removal. This allows the valve to align naturally with the pipeline. B. Release the packing gland bolts. Partially loosen to relieve pressure on the packing, avoiding excessive compression. C. Tighten the valve body bolts in a diagonal pattern. For example, first tighten to diagonally opposed bolts near the gland packing, then the remaining two. D. Retighten the packing gland bolts diagonally, ensuring uniform gland to stem clearance and maintaining gland parallelism. E. Reassemble and tighten the pipeline flange bolts diagonally to prevent flange misalignment. Post-repair testing. After reassembly, conduct a pressure test to verify sealing integrity at the valve body and packing. If no leakage is detected, the repair is complete. Long-term considerations. During operation, factors such as thermal expansion, contraction, pressure fluctuations, or internal wear, for example, ball valve seat wear, may cause leaks. Similar methods, for example, packing adjustment or body bolt tightening, can restore sealing performance. Keynotes. Flange parallelism, critical for load distribution. Axial, radial forces, avoid to prevent seal damage. Diagonal tightening, ensures uniform compression. Gland alignment, prevents packing extrusion or uneven wear. This methodology ensures compliance with industrial standards. For example, API, ASME for valve installation and maintenance.